Welcome to the second one of the two-part series where I am recording my learnings from the two major events I attended in June 2026. The first one was Snowflake Summit, and now we are going to talk about Databricks Data and AI Summit. Both took place in San Francisco, 1 week apart from each other. There was a week in between this year. So let's go through what were some of the key announcements, major event. As you will see, a ton of new announcements and market moves. More than announcements, how the market is changing. Before we get started, I want to mention to you a small plug that I have a new book coming out next month in August. It's called Designing the AI-Driven Data Foundations, where I capture a lot of my learning about what's going on in the market into this book. And there is a link in case you are interested in checking this out. So with that, let's go to the meat of this presentation. Massive event, 31,000 people, I believe from 174 countries, which just sounds phenomenal, attended in person at Moscone Center. Another 100,000 attended online. Databricks is going through a massive growth phase. Last year, end of 2026 fiscal, their revenue was at 4.6 billion. And by first half of 2027 fiscal, they are going to be at 6.9 billion, almost $7 billion. So massive increase in revenue. A lot of it is because Databricks finds itself in a very unique position. It started in the space of ML, and then AI came along. So handling unstructured data, handling AI use cases, being the front end interface for your AI workloads and a lot of token consumption is something that comes naturally to them. So they have 20,000 customers, 80% growth rate. In fact, their AI business is even growing faster at 100% growth rate. So with that, the keynote started with Ali Ghodsi, the CEO, telling us that AGI is here today, just not at work. What his point is that if you look at what capabilities AI provides now in this time, it is far beyond what we could have imagined would have been possible even just a few years ago. So from that definition, we're already in AGI, but not inside an enterprise, because within an enterprise, you need more than chatbots. You need AI to do some meaningful work, which means it needs to connect to all your data estate, whether it's inside, it's outside. It has to be governed, and you need to then be able to autonomously execute tasks. The entire conference was couched under this thing called 4 C's, 4 C's being context, control, choice, and cost. During this presentation, you will see that a lot of what I'm presenting falls in one of these four buckets. Context being how do you ascribe meaning to data which is spread across various different locations and silos, and sort of create some sort of semblance of relationship, so then you can reason over it consistently. Control is how do you do governance. So Unity catalog is an extremely important piece. You'll see that mentioned a lot, and it is basically controlling not just your data estate, but when agent goes out and calls uh, different data sources to take some action. How do you control all of that? The ability for end users to have choice of which cloud you want to be in, which model you want to use, which table format you want to use. So the open standards becomes really important. And then when you go to all these different places and agents are running amok, doing whatever they're doing, they're consuming tokens far more than humans consume, then the whole idea is how do you control cost? So with that, I'm going to show you this diagram. This diagram comes from my Medium site, sanjmo.com/medium, or sanjmo.medium.com. So sanjmo.medium.com, or my website is where I wrote my blog and I classified all my learnings into these different buckets. We will start from the very left top, which is the data layer, and then we'll go into data engineering, semantics, agents, governance, and end up at solutions, applications and solutions. So with that, let's get started with the data layer. So the first thing that we will talk about is called Lakebase. When Lakehouse concept came into existence, and before that, Lakehouse, before that, data warehouse, these are all the systems that were developed to analyze data that was produced elsewhere in an operational or transactional system. All these, a lot of these companies are saying, well, wait, we don't want to just be analyzing data produced elsewhere. We want to be in the path of creating that data. So Lakebase is an ACID operational database that comes from an acquisition that Databricks did last year called Neon, which is a serverless Postgres database. It's Postgres 17. It actually went GA only on AWS as of February 2026. So only a few months ago. Azure is coming next, and then Google Cloud soon after that. So what something interesting I have here is that Neon was founded by the founder of MemSQL, now called Single Store. Hold that thought because we are coming back to the topic of Single Store. But for now, let's focus on what made Neon such a different Postgres database. First of all, I mentioned to you it's serverless. Within 500 milliseconds, a new compute cluster can be stood up. Because of separation of compute and storage, you don't have to worry about storage. Just the compute cluster comes up. And this year, Databricks also introduced cross-cloud disaster recovery. So that is something new that was added. Now, when you write within the compute cluster a new piece of data, so this is row-based because it's operational, that data is written into behind the scenes into something called a page server, which materializes that data onto a cloud object store like Amazon S3. So that is one big difference of Neon. The second thing that Neon introduced was this Git-like branching of code. And Neon started a few years ago before generative AI was even a thing. But then when agents came up and people were using things like Replit development environment to vibe code and write the AI workloads. Behind the scenes, they started using Neon database because what happens is an agent will sense the environment based on that it'll reason, plan, and then it'll create a series of action items, chain of thought, different, and then it'll reason across them, pick the right action to take, and then take that. So when you've got multiple paths going on, then the Neon's ability to branch in near instant manner became a huge advantage for agentic use cases. The other thing that Databricks has gone ahead and introduced is something called an agent memory service, which is a persistent way to store users' preferences, history, session, state, all of that is now stored. So this is a new use case of operational database that did not exist even 2 years ago. This is not managed Postgres. This is a new category. By calling it Lakebase, what Databricks is hoping to do is that just the way they were so successful in establishing Lakehouse as a category by itself, they want Lakebase to be a category, and then obviously they want to be the leader in this category. So I told you to hold the thought about single store, because single store, what it brought to market was a concept that Gartner created a few years ago called HTAP. HTAP stands for Hybrid Transactional and Analytical Processing. So what happens in HTAP is that instead of having a separate operation store and then you ETL the data into an OLAP store, you collapse it into a single store. The mechanism to take change data from operational into analytical is called CDC, which is change data capture. So at the keynote, the database says CDC is not change data capture, it's continuous data corruption. Nobody likes CDC pipelines, they're a menace. They should never exist. The whole HTAP movement has failed for 40 years. We have fixed it and we call it Lake Transactional and Analytical Processing, or LTAP. So what HTAP did was it said that the way you query your operational and your analytical databases are very different. So behind the scenes there'll be two separate storage engines optimized for row store and columnar. What Databricks is saying is that no, that's a wrong approach. You basically have a single storage mechanism, but you have separate compute engines. So Lakebase becomes the compute engine for your operational workloads. Lakehouse is the engine for your data warehouse, Lakehouse, columnar, aggregate, bulk querying, and so on. So separate engines, but the same storage. So what is that storage? So I told you how page server gets materialized to cloud object store. Now Databricks takes that cloud object store and it instantly or very quickly it tries to write a Parquet file. And because Databricks writes now both Delta and Iceberg, it puts both those table formats on top. So that is the technique that LTAP uses. The only issue with this whole thing is that so far there is no design document or a technical paper that goes into the depths. So what I've shared with you is conceptually what happens, and we are waiting to get more information. Like for example, I'm very curious to see what is the latency between the page server to Parquet file. By the way, this transcoding is something that Databricks is also going to open source, so others can also use it. So what is that latency? And then I'm used to seeing an enterprise relation diagram for my operational and a star schema or a snowflake schema for my OLAP. How am I doing that translation? What is the performance? A lot of things are yet to come. Now, we've talked quite a bit about Lakehouse being the columnar data warehouse engine. So Lakehouse, by the way, saw a lot of interesting updates, but it took a backseat this year because Lakehouse //RT came out. So we'll talk more about that. Lakehouse itself saw something like 110 plus new enhancements, including in new AI functions. Also, Lakehouse has now moved into what is called RT, which is the real-time engine. So let's go and peel the onion a bit and look at what happens behind the scenes in a Lakehouse. You all know that Databricks as a company came out of academia. Most of their founders were at UC Berkeley. They had created something called Apache Spark, and they took that Spark engine to turn this into a commercial product. When Spark came out, That was an era when the most predominant big data engine was Hadoop. And Hadoop uses MapReduce, which was very batch. Every operation had to be written to the desk, reread, and it was very cumbersome. So Spark came out all in memory. It was a huge enhancement, but it still was not fast enough. So some years ago, Databricks decided to rewrite the engine away from Spark into a C++ vectorized engine called Photon. This year, they announced a new engine. It's called Reyden. Reyden is taking Photon as the core library, the kernel, and then everything around it has been rewritten in Rust. Things like I/O into the engine, memory management, workload management, query optimization, all of that is written in Rust, and that makes Raiden a engine that runs in tens of milliseconds, and it is now near real-time performance of it. Why is it called Raiden? This is an inside joke at Databricks. The person who created the engine, he is a co-founder. His name is Renel Zin, XIN. Renel went and created this engine, and so it got called Raiden's Dream Engine, or Raiden. So who are they going after with this new engine? Companies like Lakehouse. Also, so because what used to happen was the data warehouses of the past were amazing in high throughput jobs, but not for low latency. For low latency, people had to stand up a yet another cluster. And these were companies that were built on open source products like Apache Druid, Apache Pinot, Startree, Imply, also Star Rocks. There's some new ones. ClickHouse being another one. So now what the whole idea is that why have a separate cluster when your engine becomes so fast that Lakehouse now can serve your queries and process your data within milliseconds, and that is Lakehouse RT. A lot of benchmarks were shown, but once again, this is beta, it's read only, so we don't have a lot of information. So before I move off Lakehouse and Lakehouse RT, I also want to mention there is also a product called LakeBridge. LakeBridge is the product I've mentioned here. It sort of doesn't really belong in RT, but I'm not talking about Lakehouse, the big engine, but it moves enterprise data warehouse, migrates them into Lakehouse, and Databricks shared a figure of 1,300 migrations that have already used LakeBridge. A couple of more things before we move to data engineering. So two more slides. There is in Iceberg version 3 spec when GA same week for both Snowflake and Databricks. With V3 spec, a lot of things that were missing in Iceberg were introduced. If you're interested, I have a whole slide on that in my Snowflake Summit podcast right before this one. Here, I'm not going to go into it because we have a lot of ground to cover. But the big news is that Ryan Blue, who sold Tabular to Databricks, created Iceberg, has been tasked with making sure Iceberg and Delta Lake are at parity, and he's working towards making sure that happens by the end of 2026. And when that happens, then Parquet is a commodity, Iceberg Delta wars go away, and the wars move into the catalog and context. And so we have a lot of comments on that. But before I go there, the last slide on the data layer, here I want to talk about not all data needs to move from source to the target. Some data may stay in the source, but I still need to access it from my applications. So what is that common protocol that allows me to share data from multiple systems in a consistent manner? In 2021, Databricks introduced something called Delta sharing. And this year it got contributed to Linux Foundation. The new name is now OpenSharing, and it moves beyond data or beyond structured data into unstructured data, includes AI assets like models, skills, and so on. So this concept of being able to share data wherever it exists is the concept of zero copy. So the other thing that also was added was that there is delta sharing is a protocol, but then a lot of engines expect REST, Iceberg REST catalog APIs. So Iceberg support was added on top of Delta sharing, so you can just publish it once and then any number of consumers can consume it. That data can also sit on premises. So for example, you see here the examples of companies like Minaya, Cumulo, NetApp, Rubrik, Vast, and so on. They something that doesn't get a lot of news, surprisingly, and this is true for AWS, Google Cloud, Microsoft. They've all reduced or they've eliminated egress fees and Oracle Cloud Infrastructure (OCI). Same thing, Databricks has eliminated cross-cloud egress fee for large providers. And then security is maintained through the Super Secure Connect, which is this private VPC, so data does not get exposed on public internet. With that, I have one slide on data engineering. Lakeflow is a sort of consolidation of two major tasks that data engineers do: ingestion and transformation. So it all happens in one. There are 100 plus connectors. This is not new. Lakeflow was introduced last year. Lakeflow Designer is a low-code, visual, drag and drop, Alteryx style way to create your data pipelines. Behind the scenes, it creates Spark code. Some new things is that now you can declaratively in natural language tell Lakeflow Designer what to do, and the technique that does that is called Genie. We will talk quite a bit about Genie. For now, I've marked two new things in red because they're very interesting. Zerobus, again, is written in Rust. This is Databricks endpoint for ingesting data directly into Lakehouse without needing Kafka. Soon they're going to go GA with Kafka compatible API. The whole idea is that why have a whole Kafka cluster when you can just use Zerobus and write data directly into Lakehouse. The other thing they also introduced is this very interesting thing. This is called Spark real-time mode. So Spark has had an identity crisis ever since I've known it. It wants to be known for its low latency, but it's micro batch. And that latency was in seconds. So now Spark real-time mode was introduced, which uses Reyden. And by using Reyden, they're saying we are now in tens of milliseconds. So finally, we are at the same power as Flink. So that is a big thing. The last thing here is called Spark Declarative Pipelines. This is basically where you declare what you want to do. Last year it was called Delta Live Tables, which is now was made open source. But now Spark Declarative Pipelines come with both real-time mode and the Genie code. So just one slide. So what's really happening is that if you look at Reyden, it's a vectorized execution engine, which have existed for a very long time. Everybody is now a vectorized compute engine. Storage is commodity. So where do you differentiate if everything gets standardized? And that is when you move to the semantics and context layer. So we'll talk about Unity Catalog. This is where all the current wars are being fought. Unity Catalog semantics has this concept of you define domains, you define business glossary, and you define metrics. Why are we doing this? Is because there's a point here. Data engineers, data analysts, data scientists, they finally work from the same definitions. The idea is that there should be one standard way for me to define what a column means, what does a formula mean, a calculation mean. So that is a semantic layer. So there's also Unity Catalog metric views where you define measures. You define it in SQL and YAML. Why is this important? Is because the 800-pound gorilla in the room is Power BI. And Power BI defines it in its own language called DAX. So this is where Databricks is trying to say, look, we are open, it's SQL and YAML. It can be consumed by anybody, any SQL editor, notebook, dashboard, and of course, a Genie. Any persona can consume it. And so this is the semantic piece. Next, we will talk about context. But I just wanted to get the semantics out of the picture. Something that's very interesting that is sort of orthogonal to what I'm talking about is that the definitions of reports and dashboards which exist in Unity Catalog, these reports and dashboards are now being considered as the evaluation or eval set for agents. So you've got these deterministic reports and dashboards that have been created. If you can test an agent to see if it matches these reports and dashboards. If it does, then the agent passes the test. If not, then you need to go and fix the agent. So now we talked about semantics, what's happening in the context. So this is the aha moment, the granddaddy, one of the granddaddies. LTAP was one we saw. This one is called Genie Ontology. So what is Genie Ontology? It is this self-improving context layer on top of Unity Catalog. Unity Catalog semantics and metric views. Runs in the background. It crawls some 50 plus data sources and creates a knowledge graph of your metadata. Your data sources could be on your Google Drive, SharePoint, Slack, emails. It's crawling your tables, your data engineering pipelines, reports, dashboards, the queries that have been written, emails, even the KPIs that have been defined, and it's creating this knowledge graph. Each node of that knowledge graph is known as an ontology snippet. And Databricks shared that there are 4.5 million ontology snippets already created. Now, you may have situations where different departments may have a different definition of maybe customer churn. So they define it differently, but how do you know which is the right one if it's gone to all these sources and created this knowledge graph? So for that, it introduced a page rank like ranking. It's called OntoRank, and it ranks by how many times has a certain formula been used, how recent it was, what is a author's authority within an organization, and it creates that ranking. All this ontology snippet ranked by OntoRank is then fed back into Unity Catalog. So Unity Catalog is becoming bigger and bigger. Every time I turn around, Unity Catalog has some new thing it is storing in it. So if you talk to the purist, they basically say the number one thing that an ontology does is it creates a relationship between different nodes. And that was a term which was not mentioned in this conference. So my take is that this is the first attempt of Databricks. It'll grow into the relationship space. So next year we will see what Genie Ontology brings to the market. While this was going on, just 2 weeks before when Snowflake Summit took place, they were also very heavily into this space. They also had two layers, horizon context, which is like Unity Catalog semantics, which is explicit, defined by the user. And then they had something they announced called Cortex Sense, which is implicit that LLMs are crawling and then they're creating. So here we've got Genie Ontology. So we saw very similar announcements from Snowflake. But during this conference, two things happened. Google announced something called OKF, which is known as Open Knowledge Format, which is what they're saying is that an ontology is actually an interchange format. And we call it OKF, it's in YAML. Same day, across east the other coast, so we were in San Francisco, in New York, AWS Summit took place, and they announced something called AWS Context. And they're saying is that context is actually a service. It's a managed service. And how does it instantiate? As files on S3 in Apache Iceberg format. So once again, we are seeing that different companies are all addressing the same problem, but in their own manner. Talking about Genie, Genie is actually a family of agents. It was launched last year, actually 2 years ago, as a natural language interface. Now it's grown into a family of 5 different agents. The most important one is Genie 1. This is what, again, going back to Snowflake, they announced co-work, which is for knowledge workers from like finance, marketing, sales. They can go and ask any questions. Genie 1 is that agent. It sits on top of Genie Ontology, so it needs ontology to be able to translate these natural language queries that are being sent by knowledge workers and translated into the query that will run underneath. Genie Code is the autonomous agent that Databricks claims 60% of their work is now being done by Genie Code. So all your data engineering pipelines, your feature engineering, analytics, you can now use Genie Code to do it. When you create these, you use Genie Code, the agent creates your code. That code can be then stored as reusable agent in something called Genie Agents. Genie Agents is actually renaming of last year's Genie Spaces. For those who are into vibe coding, you can use Genie App Builder. And then talking to a lot of Databricks engineers, their favorite Genie in this family of 5 is called Genie Zero Ops. Genie Zero Ops is the observability kind of thing that is a background agent that is analyzing how the pipelines are running. So it's doing this monitoring. It's detecting if there are any anomalies. If so, it proposes fixes. So the Zero Ops is a very powerful agent in the family of Genie. Once again, Databricks wants to capture this market. So they're saying anybody and everybody on our platform gets $10 of credit for free to use Genie per month. So that is their PLG moment of getting people to use Genie. So the other thing which has existed for some time now is Agentbricks. Agentbricks is a platform where you build your agents, but it's moving more and more into any model, any harness, more focused on production, monitoring, deployment. So the scope of Agentbricks so the product is getting more mature. Databricks claims 100,000 plus agents have been created, very tightly linked to Unity Catalog. And the idea is that this is like a harness, because model is only 1% of the work. It's a scaffolding where you're doing your evals, your auditing, your governance. That is the most important thing, and that is what Agentbricks brings. So talking about harness, another big announcement was something called Omnigent. The idea that Databricks has is that we know that not everybody's going to come to Databricks to build their agents. They'll use whatever harness they already are, and every other company in Silicon Valley is now creating some sort of a harness. So there's no commonality. Each harness is an island of its own. If you use more than one harness, you're constantly copy pasting your data from one to another. So why don't we give you a meta harness or a harness of harness where you continue using a harness? We will make sure that there is some sharing of common metadata beneath it. So that way, Databricks becomes a front end, and you don't go straight to OpenAI Codex or Anthropic Claude Cowork. You actually go through Databricks. These tools become sort of sub agents. And then also, when you are doing your experimentation and you need some place to do your experimentation, they sign partnerships with these serverless neo cloud, not these serverless companies like Model and Daytona that give you sandboxes that stand up. You do your experimentation, and the moment you're done, these instances or sandboxes go away. So this is their product is called Omnigent. It consists of an agent registry, so you can record all the agents and inventory of agents, and it's open source. So that's the other big thing. What Databricks is also offering is something called managed Omnigent with much tighter connection to Databricks and something called Unity AI Gateway, which we'll see in a few minutes. And they give you a built-in sandbox from Databricks, which is called Lakebox. So that is Omnigent. And with that, let's move into governance. This is the second part of Unity Catalog. We talked about semantics, we talked about context, but how do you secure and protect your entire estate is the job also of Unity Catalog. So Unity Catalog used to be for data assets, but now it has been expanded into AI assets. So what are these AI assets? So they are models, agents, MCP services, reusable skills. So it is now tracking all of your AI assets. It has MCP connections to a number of different places, and the idea is to give you a lot more control over which model you want to use. It also has things. So one of the things that we're starting to see is that in data governance, we were very used to governing data mostly at the source because deterministic systems always produce the same response. But in AI, we also have to govern at runtime. For example, if we determine that an agent has access to PII data, then that agent is barred from sending any external emails. So this is something that was determined at runtime. And this is an example of something called a contextual service policy. Because now we are in the realm of MCP servers, so we are going beyond our own four walls. So we are now into multiple agents, different harnesses, different MCP servers. They all need some sort of consistent governance, single authentication. So this is the purpose of Unity AI Gateway. When you've got agents going elsewhere, cost becomes a first-class citizen. How much money is being spent, who's spending it, creating budgets, even at user levels, putting limits becomes really important. So Unity AI Gateway is centralizing agent monitoring, cost management, and security across different frameworks. All the logs that get created and traces, they all flow into something that we're going to see next called LakeWatch. You can query it using Genie, and you, of course, have Unity Catalog do the security and governance. If Unity AI Gateway detects that a model is too expensive, then they can do something called smart routing. They can pick a model by task and fail over to a cheaper model and reduce your cost. They're creating a whole ecosystem around it. CrowdStrike, Palo Alto Network, Zscaler, Okta, Ping, etc. are now part of that. And so with that, we go to the last section. So I've got two slides here, and then we'll summarize. This is the last section on application and solutions. By the way, I'm talking about two solutions, LakeWatch and CustomerLake. I'm not talking about a whole slew of slides that I could have on Databricks apps. Databricks also wants to be the platform where you build all your apps, and it's also a marketplace. So that is something for next time. But it is getting into horizontal spaces. For example, it is also declared that SIEM, a SIEM, is not working. It is legacy, it is batch, it's outdated. So we now are getting into the SIEM space. And it's very interesting if you look at what protocols and standards are being used. OTel, or Open Telemetry, is a standard through which you have a common way of ingesting data. When log data is created, there is now a standard called OCSF by AWS, Splunk, and a few other companies. So the format is standardized. So Open Telemetry for ingestion standard, OCSF for the format of the log, and then you store it as Delta or Iceberg in Lakehouse. So using all open standards, you then put Genie agents on top to query it, Claude for reasoning. But SIEM also comes with a lot of workflows. So how do you get those workflows that have been built into Splunks of the world and all these other products? For that, they acquired a company called Panther. It's an AI SOC platform that then will sit on top of LakeWatch. This is the third acquisition after Antimatter and SiftD.ai. Last slide on yet another expansion into another space, which is called CDP, Customer Data Platform. This is where a lot of audience management happens, attribution of marketing. It's a MarTech space, so marketing tech. And what Databricks is saying is that if all your data is in Lakehouse and you have to do all kinds of campaigns and things like that on top, why move that data out? Because it's a security issue. So let us bring all the CDP capabilities on top of Databricks, and then now all of a sudden you have a built-in CDP. When I walked around the expo floor, I ran into all these companies. Some do master data management or some other things. They all basically expect that by next event, Databricks would have moved into their space as well. So it's a huge growth opportunity for Databricks. So with that, I am going to end here because this has already gone on for quite some time. So last slide, what are the three takeaways? Put everything into the lake. So as you can see with not just LTAP, but LakeWatch, CustomerLake, all of that, make governance be the moat, and then make sure that you are reducing the cost footprint for your customers by doing that. So with that, we will end here. Thank you so much for staying till the very end. It was a pleasure talking to you. Until next time, we will talk to you again. See you.